Hello and welcome back. So in this video we are going to be looking at another point. It's going to be profiling and the use of formulas. So I decided to make this third point profiling because all the while we've been writing code and optimizing code, but we don't actually know the performance of this code. So what you're supposed to do is you write this code is working fine and then you try to profile it. Profiling is simply when you're trying to measure the performance of your code in terms of the amount of memory being used by each section of the code, the data you have, the objects you have, and also how much time it takes this code to run. That's what profiling is all about. So in profiling we look at two things. We can profile time, we can also profile memory. So once you look at the amount of time taken by a particular section, then you need to ask yourself, is it worth my time to spend that extra moments to profile, to optimize this code? Or when it comes to memory, if a particular data structure is occupying too much time, too much memory, you need to ask yourself, do I really need to see if I can use a different data structure so that this code is going to occupy less memory? Now we have different ways when it comes to profiling in terms of time. We can use the command prompt, and that's what I'm going to be looking at in this video. But when you're using the command prompt is actually meant for Linux, not for Windows. However, if you're using Windows, you can actually do that by installing Git, because Git comes with the Git bash command prompt, so it's better you install that and then you can actually go ahead to use your Windows operating system to go through this first method. So we are going to use a command prompt in this video. Now in order to illustrate how to profile time in your program, we'll be making use of these examples. So it's going to be a program that is going to sum the squares of the first n natural numbers. For us to do that, we have this formula we can make use of: 1 squared plus 2 squared plus 3 squared down to n squared. If I try it for 3, when I substitute 3, my result is meant to be 14. When I substitute 5, my result is meant to be 55. But we are going to increase what we are going to use, maybe 100, 1000, and see the amount of time it's going to take this program to run. Okay, so let's move down to our IDE and start working on this. So I'm going to be using Visual Studio Code. First I'll move down to this folder where I store my codes and create a new file. I'll call it sum of natural square, if that's a good name, .py. So I'm not going to use IPython notebook for this because I have to run this script on the command prompt, and for it to run this script on the command prompt it needs to be a .py file. Okay, that's what we are going to do. So I'll use a function. I have def, I'll call it sum of squares. That's what I'll call it. That's the name of the function. It's going to take in n, and what's meant to do first is to initialize the result to be 0. I'm initializing the result to be 0 because at each iteration I want to run through this loop and increment this result. So I'll be having 0 squared plus 1 squared. That's what basically I'm trying to get. So I want to have something like 0 squared plus 1 squared plus 2 squared and so on. Okay, that's what I want to be having. So let's see how we can do that. So what we need to do is to use a for loop. So I'll say for x in range. So I want my range to start from 1, no longer 0, because I already have 0. So I'll be taking 1 square, 2 square. If I say down to n, for instance, if the user enters 7, it's going to stop at 6 because the range function does not take the last index. It takes what is before the last index. So I'm going to make it n plus 1. So that's going to take the last index. So if I give it 7, this will become 9, and this will become 8. And for the fact that this is 8, it is going to stop at 7. So that's the reason I'm using n plus 1. And what I'm going to do now is to pick the result, then augment it. I'm going to use augmented assignment. So I'll say plus equal to x squared because I'm using x there. And that's all. So all I need to do now is to return the results, where the result is actually results. So this is all for this program. Let's test it. So for me to test it, I need to actually execute the program by calling sum of squares and passing a value. So let's pass in first let's pass in 3 to test and see if it's actually working fine, because I think by passing in 3 we are meant to get our result as 14. I think that's what we have there. When we pass in 3, our result is meant to be 14, and when we pass in 5, our result is meant to be 55. Okay, so that's what we are going to test. So let's test that and see. So I'm going to pass in 3 and run this program. So I'll save this and run the program to make sure it's working fine. What do we have? We have a result as 14, so that's okay. So let's pass in 5 and see what we have a result as. So pass in 5 and then we have a result to be 55, so it's working fine. So now we are going to profile these codes. Okay, so let's profile it using the command prompt. Now if you notice, I'm using git bash here, so I can easily profile even if I'm on a Windows operating system. So what I need to do is to start with the keyword. That's what you always do. You say time, then Python, you leave a space, then the name of the script. But before you do this, you always make sure you navigate to the directory where you have this file saved. Okay, so right now I'm not in that directory because I'm in Fast and Beautiful Code, and this is about it's meant to be within Fast and Beautiful Code under codes. Okay, so I have to move down to code, change directory to code, then this is where I'm going to do that. So I'll say time, Python, the name of the script, which is sum of squares natural, and that is it. So let's see what it's going to give us as a result. So it's saying we have 3 outputs here: real, user, and system. Okay, so what's different between these? The real is the time spent by your system in computing your code, including time spent on other processes. So maybe you have some other tasks going on in your background, other heavy tasks and the rest of that. So this real takes note of all the time, okay, the one spent by your system on this actual program and other processes that are running on the background. This user, this is the time spent on your program, and this is the time spent on the kernel. Okay, the kernel in producing. So what you should always do is to look out for the sum of user and system. So if I sum user and system, whatever I get becomes my result. That's what I should use as the benchmark. So if I sum these two now, I'll get my result as 0 minutes 0.015 seconds. So that's what I'm going to use as the benchmark. But now let's increase this to 1000, or let's make it 10,000 and see how much time it's going to take us. So I've increased it to 10,000. Let's run this code and see how much time it's going to take us this time around. So that's taking us, and this is not okay. Yeah, I didn't actually do that, so I've increased it. So I'm going to say time Python, and I forgot to do that, you see. So Python, then sum of squares .py. So let's see. So this time around the program takes including other processes, taking about 0.111 seconds. The time spent on the system is about the time spent by the user, which is in processing this code, is about 0.015 seconds. On the kernel is about 0.000 seconds. So in total, if I sum these two, I'm still going to get 0.15 seconds, 0.015 seconds. Now this is not a good approach using the command prompt, because for me I don't trust whatever result is given by this. Okay, I don't trust that. So in the next video we are going to see how to use another method in profiling our code instead of using the command prompt. So we are going to be using a model called the time model in the next program. Okay, so we'll be testing 2 different versions of writing this code, how to use this process, and also how to use the formula that we have for sum of squares of natural numbers. So that's it, guys, for this video. If you like this video, it has helped in any way, please do well to subscribe to the channel, and also make sure you click on the bell icon so that you get notified whenever I upload new videos, because I upload videos every week, at least 2 videos every week on different series. Okay, so I'll see you guys in the next video.